Hi everybody. As I told you last time we were together, on Tuesday and Wednesday of this week I will be in Denver at a conference to make me a better earth science teacher. As you watch this video, that's exactly where I am. You have a sub today, and I have asked him or her to show you this short video to get you started on some activities that we will be engaged in for the next couple of class periods. As you can see, I'm sitting in my office the day before you watch this video with my cup of coffee, kind of getting you guys started on this on a good foot. What we are going to be doing is measuring various variables in the environment and using that to understand not only our ability to measure through data probes, but also the principles of meteorology. I'd like to start off by introducing a couple of pieces of equipment that we're going to use. One is that we have sensors of various types. This is a barometer, barometric pressure sensor, and you'll notice that it has a interface cable that goes through a interface device and then through another cable into a USB port. And all the sensors work basically the same. I also have available to me a relative humidity sensor, and that is placed into a controlled environment right now, and I'm going to explain that, and that's the lion's share of what this video is about. And lest I forget, you must have the computer software provided so that you can collect data and then process it for use. I've placed that onto my school supplied laptop, and you will also have it available in the computers that you will be taking these measurements through. Alright, let me get to the point of why I have this relative humidity sensor in this container. Yesterday, when I first hooked up the relative humidity sensor, I began to take readings. It worked perfectly, and it read roughly in the neighborhood of 35% humidity. It kind of bounced around, and then it settled down after a little while. And I thought, 35%, let me see if that's an accurate reading. Being of a skeptical nature, I went onto the internet, and there are a number of really good sites that you can go to, weather sites. Wonderground is one. Some other ones like weather.com, you might have to dig a little deeper to find specific weather data. They might just tell you it's cloudy and might rain a little bit. But Wonderground I really like because they show you in your location what the relative humidity is, what the wind direction, wind speed is at the time, your temperature, and some forecast information, and generally very accurate. And it was reading 75% relative humidity, yet I'm reading 35% relative humidity. So that got my curiosity that I talk about all the time in class. It got that going again. And I thought to myself, perhaps my measuring device is out of whack slightly. So I thought to myself, perhaps I should calibrate this. I looked in the documentation that I've received with the unit, and it specifically states, no, you don't have to calibrate this sensor, but then right underneath that it gives you a calibration procedure, telling me that sometimes you do need to calibrate the sensor. So I went through the process. And any calibration procedure is basically a situation where you provide a predictable set of circumstances for a sensor, and then you tell it this is what it should be reading, and then you look at what it does read, and you compare the two, and if it's off from that, that's how much it needs to be adjusted. So in this case, what we did was, just as the directions implied, we created a unique environment in which a predictable humidity situation would take place. And what they told me to do was take a handful of salt, and I just used sodium chloride, common table salt. There's many other kinds of salts out there, and you will soon be in chemistry, some of you, and you will find that salts are come in many varieties, but of course the one that we all have in our homes is table salt. So I took table salt, put it in the bottom, put some moisture in it, and that was one of the requirements. They didn't want me to dissolve the salt, they just wanted me to get it damp. And then they made a big point about keeping the sensor out of the salt because it would damage it. So I cut a toilet paper tube into 1/3, 2/3 proportions, cut some grooves in it, and then it created a little saddle where my sensor could sit inside of that stand, if you will, and stay out of the salt, yet still continue to measure the air inside. Cover that with plastic, rubber band to seal it, and then a twist tie to take care of this last little portion where it could make contact with the outside air. So now it's all sealed off. I left it in there for 6 hours and took readings, and it stabilized out at 70% humidity. According to the table that I was given, at the given temperature, which is one of the key variables, at the given temperature of 20 degrees centigrade, and I just took my temperature, my thermometer that I have in the kitchen, and I changed from my commonly used Fahrenheit over to centigrade, and when I put it to centigrade, I adjusted my heat in the house to be exactly 20 degrees centigrade. And when I did so, I looked at this chart, and it says that it should read 75.47, and it was reading steady at 70%. So I thought to myself, that means it's 5 degrees off. I adjusted that in my computer so that the temperature probe was now calibrated to read 75% instead of 70. So now I was confident that it was reading what it should. So my 35 then became 40. The original 35% in my home was now reading 40, but I thought to myself, it's reading 75 according to Wonderground outside, and then inside it's reading 40. So there's a 35% difference in there. But one thing stuck in my mind, that when I was looking at the calibration chart, that temperature is a key to how much the relative humidity should read in an environment where the moisture is consistent. At 15 degrees centigrade, for sodium chloride, the relative humidity should read 75.61, whereas when you increase the temperature, the relative humidity goes down. So I thought to myself, so what would happen if I was to take a given unit of air from outdoors and bring that inside the house and heat it up? Well, of course it would expand, the molecules would get farther apart, and as we discussed once already in class, the air mass would then have a slightly higher ability to hold moisture. And the way that relative humidity is calculated is it's the amount of water in relation to what the air is capable of holding under those temperature and pressure conditions. Pressure didn't change from inside to outside, but temperature did. So now that we warmed up this air, the relative humidity reading should go down. I wanted to verify that principle, so I called up a local expert, which is one of the ways that we can verify suspicions we have. We can consult a textbook, a teacher, perhaps a local expert that we can call upon. Well, I'm lucky enough to have a friend in the local weather squadron at Fort Drum, and I called him. He didn't answer, but I was able to talk to another meteorologist, and I got Sergeant Snyder confirm my suspicion that when you bring this air mass indoors and heat it, that you will then have a much lower reading on your relative humidity. And that explains why our houses are so dry in the wintertime and so humid in the summertime. Because we don't have the big difference in temperature in the summer, but we do in the wintertime just from heating the air. So I was able to verify why that is, verify that my instrument was reading correctly, and then understand that the humidity inside the house is the same amount of moisture perhaps, but a lower relative humidity reading. So we've learned a couple of things here, and before you get going on your activity that your sub will steer you into momentarily, I'd like you to remember a couple of things here. First of all, remember what calibration is, that instruments all need to be calibrated periodically. Sometimes vibration, impact, things of that nature can disrupt their ability to measure properly. Also, I want you to remember that warmer air has more capacity to hold moisture than cooler air, and that affects the reading of relative humidity. It's also important when in doubt to ask an expert when you need verification of something that you're trying to solve. And lastly, I want to leave you with this. Curiosity drives science. And if I leave you with one thing after this year of Earth Science, I want you to remember that curiosity makes science fun and curiosity gets science done. And you remember that, and you will be a lifelong learner. Now get to work. Your sub will help you to get started on this activity.